concentration of oxygen. Normally, the air around us is about 20% oxygen. Under these conditions, it falls to less than 10. It's not enough for us to breathe or sustain fire. While lightning lashes the planet, fire doesn't burn. For now, even though lightning strikes, our buildings survive. But worse is yet to come. What's left of our planet is going to change even more dramatically. Our sun is aging rapidly, marching inevitably to its death. This is the sun as it would be 4 billion years from now. The remaining hydrogen in the sun's core is under tremendous pressure, crushed by the weight of the outer layers. Hundreds of millions of tons of hydrogen are fusing together every second. It's an Earth we barely recognize. The surface of the planet is now 700 degrees and rising. It's too hot for us to survive. Even the most sophisticated suit can't protect us from the blistering heat. And we can't survive underground either. At these temperatures, human life on Earth is finished. Every last drop of water on the planet is evaporating. The oceans become vast, salty deserts, sucked lifeless. As the oceans vaporize, Earth is shrouded in clouds, which reflect the sun's rays. But that doesn't make it cooler. The heat is trapped in this gas envelope. But heat isn't the only punishing problem. The air pressure on Earth is now 270 times what it once was. If humans were on the planet, it would feel like every square inch of our body was being crushed under the weight of 4,000 pounds. Eventually, pressurized containers are destroyed, crushed by the Earth's enormous atmosphere. But even highly volatile liquids like propane and gasoline still can't burn. In these conditions, there's not enough oxygen to sustain flames. But the extreme heat is more than enough to begin melting what we've left behind. Polyester and plastics turn into a molten mass. The extreme temperature also marks the death of anything made of concrete, which was created with water. Now, in over 700-degree heat, this trapped water evaporates explosively, turning the concrete brittle and dusty. The metal rebar inside the concrete, which gives it added strength, expands in the tremendous heat. Combined with the evaporation of the moisture, the effect is dramatic. Some ancient monuments are still able to withstand the heat. Even 700 degrees isn't enough to damage the limestone of the pyramids, or the sandstone that makes up Stonehenge. They wouldn't melt just yet, assuming they were still around. But these incredible temperatures aren't stable. 700 degrees isn't anywhere near the most extreme the world will see. The greenhouse effect gets worse. Temperatures shoot up towards 2,400 degrees. This last radical increase is the beginning of the end. More and more of the water vapor circling the planet escapes our atmosphere and travels into space. Water that makes up the clouds is bombarded with UV radiation from the sun. The radiation splits the hydrogen off from the water molecule. As the hydrogen escapes to space, the oxygen stays behind, and the world is remade. About 5% of the Earth's crust is made of iron. As the oxygen returns, the iron rusts, and the planet begins to turn red. As the oxygen levels climb again, the extreme temperatures spark a deadly cycle. There's enough oxygen for fire to return. Anything that survived now burns. Even without the fire, the limestone of the pyramids now crumbles. And the sandstone of Stonehenge melts. The last artifacts of our existence return to the planet. Earth is now a scorched, rusting world. The sun is just 40% brighter than it once was, and what's left is completely consumed by fire. The sun that gave us life now has scorched the planet bare. This is the Earth.